Okay, I'm sorry I didn't put the title here, but my research focus would be on precipitation in the maritime continent, and it would be focused on my country, Indonesia, and it is located in the tropical area. It consists of 60% sea and more than 13,000 islands, and it is often referred as a maritime continent in atmospheric science terms. And Indonesia is a part of Southeast Asian community, and Southeast Asian community itself is now one of the biggest emerging economic power, and Indonesia is their biggest contributor. And economic activities in Indonesia itself consist of agriculture, mining, fisheries, and tourism, etc. And they're all climate-sensitive sectors. And when we're talking about climate, we often think about temperature and precipitation. As you can see in the figures, that compared to the rest of the world, Indonesia is hotter and more wetter and more humid. That's why we only have 2 seasons here, dry season and wet season. But since the variability of temperature in Indonesia in short temporal scale and long temporal scale is not very much significant, so in my research I would only focus on precipitation. And the maritime continent has 3 distinct characteristics of precipitation, which are affected by various, which are driven by various mechanisms. And maritime continent itself, it is also a very complex regional atmospheric systems in the world, so that it would be very difficult to do a forecast or a short-term forecast or even long-term forecast. So that's why in my research I would like to do a regional climate simulation, specifically on this area, the maritime continent. And the regional climate simulation itself is a process of resolving physical atmospheric process through numerical simulations. And you can imagine it as like in this figure, when a better representation of topographical response is obtained. And it would, of course, require an enormous amount of computational resources, so that's why I want to do it probably in the supercomputing facilities here. And the output of the simulation itself would be can be processed and analyzed into a climate information data sets, such as rainfall, monthly rainfall, seasonal length, onsets, and so on. And of course, it would add some values into the operational climate forecasting, as well as adding reference for climate modeling communities, for tropical climate, for rainfall modeling, and it can be also as an entry point to local scale climate change impact analysis, since this process and these practices can be done also for future climate data sets. And in a broader sense, the contribution I would divide it into 2, the short-term and long-term one. And for the short-term, it's mainly for hydrological purpose. As I said before, since the main economic activity is agriculture in Indonesia, so a better product of seasonal forecasting can help increase the production in agricultural activities. And climate literacy can also help farmers, modern or traditional, to improve their production and increase the yield. As for the future climate projection data sets from this research output can be applied into some sectors such as spatial planning, energy, ERR, disaster risk, and of course environmental issues. And that's all I have. Thank you.